Roman concrete is still standing. Modern concrete crumbles in decades. The difference isn't the recipe, it's the supply chain. Here's the bold claim. Roman builders didn't just mix better cement. They engineered a cost structure so efficient that durability became inevitable. And we're going to prove it by walking through the economic machinery they built piece by piece. Exhibit 1: the volcanic ash. Around 2,000 years ago, Rome had access to pozzolana, a fine, silica-rich powder from volcanic regions near the Bay of Naples. It was cheap, abundant, and geographically locked into the Roman supply network. That mattered because economics rewards what's local. When you can source raw material from nearby quarries instead of shipping it across continents, you cut transportation costs by orders of magnitude. That meant Roman engineers could afford to use more ash per batch. More ash meant a denser, more resilient concrete. Economics didn't just allow durability, it demanded it. Exhibit 2: the labor model. Roman concrete wasn't mixed in factories. It was mixed on-site by enslaved workers and hired laborers in batches timed to the construction schedule. That sounds brutal, but economically it solved a massive problem: waste. Modern concrete is mass-produced. It sits in trucks, it has a shelf life. If you don't use it within 90 minutes, it hardens and becomes scrap. That creates pressure to rush the pour, to skip curing time, to cut corners. Roman batch mixing eliminated that clock. Fresh concrete every time. Exhibit 3: the curing protocol. This is where the economics get subtle. Roman builders didn't just pour and move on, they had time. They had incentive structures built into their contracts to stay on site, monitor the cure, add water, manage temperature. Patience was baked into the cost model. Modern construction operates on speed. Projects are bid on timeline and budget. Curing concrete properly takes weeks. That's dead money sitting on a job site, so contractors pour thinner, rush the cure, move to the next job. The concrete hardens, but it's weak. It'll fail in 30, maybe 50 years. Exhibit 4: the ingredient philosophy. Romans added seawater to their concrete. Counterintuitive, right? Seawater is full of salt. Salt corrodes steel. But Romans didn't use steel reinforcement. They used stone arches and gravity. Seawater actually improved the chemical reaction, made the concrete denser. Modern concrete is reinforced with steel rebar. Steel needs protection from salt and moisture. So we add expensive waterproofing, sealants, drainage systems. We're constantly fighting the material, patching it, maintaining it. Romans engineered with the environment, not against it. Lower cost, better results. Exhibit 5: the structural design. The Pantheon's dome is 5 meters thick at the top. It gets thicker toward the base. That's not decorative, it's economics. Thick concrete at the stress points costs more in material but eliminates the need for expensive repairs and replacements. The upfront cost buys centuries of zero maintenance. We call that total cost of ownership. And it's the hidden economic truth. Roman builders calculated the lifetime cost, not just the construction cost. Modern developers calculate quarterly earnings. That difference in time horizon changes everything about how you build. Exhibit 6: the supply monopoly. Rome controlled the volcanic ash regions. They had a stable empire, stable trade routes, stable labor systems. That meant consistent material, consistent quality, consistent recipes passed down through generations of builders. Modern concrete suppliers compete globally. Every batch is slightly different. Variation is the enemy of durability. Slight changes in water content, ash ratio, curing temperature, they compound over time. Roman consistency meant predictability. Predictability meant reliability. You can't engineer 1,000-year durability with batch-to-batch randomness. So here's what we've established. Roman concrete outlasted empires not because Romans were smarter chemists. They outlasted empires because the economic incentives aligned with durability. Cheap local ash, on-site mixing, patient curing, structural redundancy, monopoly supply, long-term cost thinking. Every single one of those factors would cost more money today. Sourcing volcanic ash from Italy instead of Portland cement from a local supplier, that's more expensive. Mixing on-site instead of in a plant, that's more expensive. Waiting weeks to cure, that's more expensive. Overbuilding for durability, that's more expensive. And that's why modern concrete crumbles. Not because we forgot how to build. We didn't. We optimized for a different variable. We chose speed and short-term cost over durability. The Pantheon has stood for 2 millennia. Most modern buildings are designed for a 50-year lifespan. That's not an accident, it's an economic choice. The real lesson isn't about concrete, it's about how economics shapes every material we touch. Every price tag contains assumptions about what matters: speed or durability, profit or legacy. When you understand those assumptions, you understand why things cost what they cost and why they last as long as they do. This video is for educational and informational purposes only and is not financial advice. Always do your own research. Subscribe to uncover the hidden economic forces behind the materials and systems that shape our world, new supply chain mysteries every week. This video is for educational and informational purposes only and is not financial advice. Always do your own research.